Section 7.2.49-T. The number of chocolate chips in a bag of chocolate chips cookies is approximately normally distributed with a mean of 1264 chips and a standard deviation of 116 chips. Determine the 28th percentile for the number of chocolate chips in a bag. So let's make sure that we understand the definition of 28th percentile. So the 28th percentile means that 28% of the data is less than the random variable x. That is, the area under the normal curve to the left of x is equal to 0.28. So let's draw that normal curve so that we know that what we're talking about here. So here is our bell curve. Okay, we know that the mean from the given problem is 1264. Okay, and what we know is that there's a value of x that is shaded of an area to the left of that value of x has an area of 0.28. So now let's go ahead and use the table in finding the z-score of this. So what we would have to do is we need to find the z-score. Okay, so what is the z-score when the area is 0.28? So let's go ahead and look at that. So let's go find the area of 28%, which is 0.28 down here. So let's look for 0.28, 0.28. Okay, so it's between those two values down here. So let's go ahead and do that. So 0.28. Okay, so now what we want to do is we want to check, okay, where is 0.28? Is it closer to 0.2810? So when we take a look here at 0.2800, we can see that it's going to be closer to this as opposed to this. So we know it's closer to 0.2810. So that means we're going to use this area. So let's go ahead and it's going to be negative 0.58 as our z-score. So it is negative 0.58. And so now what we want to do is we want to use the formula x, which is equal to the mean plus the z-score times the standard deviation, which is 1264 plus negative 0.58 times the standard deviation of 116. So let's go ahead and put that in our calculator here. So we have 1264 plus negative 0.58 times 116. And so that gives us 1196.72. Okay, so now what happens when we use the calculator? Okay, so we're going to use INV norm. Okay, so let's go ahead and do that. So we know our area. Okay, we know that our what our mean is and what our standard deviation is. So if we want to find the variable x, then we know that we're going to use the area to be 0.28. So again, INV norm 0.28 with a mean of 1264 and a standard deviation of 116. So let's see what that gives us. So we have second distribution Go to INV norm. Our area is 0.28. Mean is 1264, and our standard deviation is 116. Okay, let's take a look at that number there. Okay, so we get 1196, but that's 1196.3. Okay, down here we get 1196.7, and they want us to round this to the nearest whole number. The result on my math lab is going to be 1196. So we want to be able to use this information and use technology to get our result. So the answer is 1196 as opposed to 1197. So therefore, this is our answer. Okay. Now, let's say we wanted to use StatCrunch. So if we wanted to use StatCrunch, okay, we're going to go to Stat, Calculators, we're going to go to Normal. Okay, and again, what we want to be able to do is, we know that our mean is 1264. We know that our standard deviation is 116. And then over here, we know that the area is 0.28. So let's go ahead and compute. And you can see what we get there. So we're going to get the same result. So we get, rounding it to the nearest whole number, we're going to get the same result. We're going to get the value of x to be 1,196. So therefore, we can say that the 28th percentile for the number of chocolate chips in a bag of chocolate chip cookies is 1,196 chocolate chips. Okay, now in part B, it's asking us to determine the number of chocolate chips in a bag that make up the middle 96% of bags. So if we want to find the middle 96%, that means that we know our area is 0.96. When we draw our bell curve, again, we know that our mean is 1264. And then this is going to represent the middle 96%, which becomes 0.96. So we want to find out, this is x1 and then this is x2. So now what we want to do is we want to be able to find the areas in this and there. So what we're going to do is we're going to take 1 and then subtract 0.96. That gives us 0.04. And then we're going to divide that by 2, which gives us 0.02. So that means that this area is 0.02, and we know that this area is 0.02. So in order for us to find x1, we're going to use the calculator function of INV norm. We know the area to the left of that is 0.02. We know that our mean is 1264, and we know that the standard deviation is 116. So let's go ahead and put that into our calculator. Second distribution, we're going to go to INV norm. We have 0.02, comma 1264, comma 116. And let's go ahead and copy that. So now we know that this is going to give us 1026 if we round it to the nearest 1,000. Okay, now what we want to do is we want to find x2. So we're going to use, again, INV norm. Okay, but what we need to do is we want to find everything to the left of x2. So we can either use 0.96 plus 0.02, which is 0.98, or we can say 1 minus 0.02, which is 0.98. So we can put in here 1 minus 0.02. We have a mean of 1264 and a standard deviation of 116. So again, let's go ahead and do that. Second distribution, INV norm. We know that we have 1 minus 0.02, comma 1264 with a mean standard deviation of 116. And so therefore, let's get that result here. So therefore, if we round that to the nearest whole number, that becomes 1,502. Okay, now let's say if we wanted to use StatCrunch. Okay, so we know what our area should be. It's 0.02 and 0.02 here. So we need to at least go from 1 to 2 before we start our StatCrunch. So let's go ahead and do that. We're going to use our calculator here. We know that our mean is 264. Our standard deviation is 116. And we want to find what is the value of x when the area is 0.02. So we're going to change this area to 0.02 and then select compute. And then you can see what we get for that result. We get the same thing that we got for rounding it to the nearest whole number. Okay, and then we're going to go ahead and do the next one. So now we want to make sure that we're using, okay, we still have 1264, we know we have 116, right? And so what is this area now? We want to find the area that's to the left of x2. So the area to the left of x2 is 0.98. So when we put 0.98 in there, we can see that we get the value of x. And so by looking at that, we can see if we round that to the nearest whole number, then we get the same result over here. So therefore the answer here tells us that the number of chocolate chips in a bag that make up the middle 96% of bags is 1226 to 1,502. So therefore, this is 1026 here for x1, and then for x2 is 1502. Okay, next, it's saying we want to find what is the interquartile range of the number of chocolate chips in a bag of chocolate chip cookies. So let's go back and talk about the definition of the interquartile range. Well, recall that the interquartile range, IQR, is the range of the middle 50% of the observations in a data set. That is, the IQR is the difference between the third and first quartiles and is found using the formula IQR, which is equal to Q3 minus Q1, where the first quartile, denoted Q1, divides the bottom 25% of the data from the top 75% of the data, and the third quartile, denoted Q3, divides the bottom 75% of the data from the top 25%. So let me go ahead and move this down just a little bit here so we can use this information. Okay, so what that means is, let's go ahead and draw that using our bell curve. Okay, so if we have a bell curve, and again, we know that the mean of this is 1264. Okay, so we know that this represents quartile 1, and that's the bottom 25%. So this is 0.25. Okay, and then we also have quartile 3. Okay, now remember, this is the middle 50%. So the middle represents 0.50. And we know that this also represents 0.25. So we're going to do the same thing that we did above. Okay, we first want to find quartile 1. And quartile 1 is going to equal INV norm with an area of 0.25. We know that 1264 is the mean, and then 116 is the standard deviation. So let's go ahead and do that. So we have second distribution INV norm we know the area is 0.25. We know that it's 1264 for the mean and then 116 for the standard deviation. And so we're going to get, we're going to round that to the nearest whole number. So therefore Q1 is going to equal 1186. Okay, and so now what we want to do now we want to find quartile 3, and we're going to use INV norm. Okay, so that means it's going to be the bottom 75%, which is what they said. So that means that this is going to represent 0.75 or 1 minus 0.25, and that's 1264 and then 116. So let's go ahead and figure out what quartile 3 is going to be. So second distribution INV norm, we have 0.75, 1264 is our mean, and we know that 116 represents our standard deviation. So let's go ahead and copy that. So let's go ahead and round that to the nearest whole number, which becomes 1342. Okay. So now we're going to, in order to find the interquartile range, we take IQR, and that's equal to Q3 minus Q1. So that means we have 1342, and we're going to subtract 1186, which gives us a value of 156 for the interquartile range. And so therefore we can say that the interquartile range of the number of chocolate chips is 156. Okay, now let's just go over how we would put this into our StatCrunch, okay, to give us the same results. Okay, so again, we're going to have to make sure that we cover, number one, drawing our diagram. Okay, and so again, we know that the mean is 1264. We know the standard deviation is 116. But in order to find quartile 1, we got to use the area of 0.25. And then we're going to select compute. And then you can see what we get for the value of quartile 1. Okay, so here's quartile 1. And then quartile 1 rounded to the nearest whole number gives us 1186. Okay, and then we're going to come back again using the same mean, the same standard deviation, but now the area that we want to the left of quartile 3 is 75%, or that's 0.75. And then we're going to select compute. And so now, once we have that number here, then we can find the interquartile range as we did in step 4 by subtracting those numbers and getting that result.